In the last session, we have seen about the bus zone protection using differential protection of bus bars. So, there we have seen the drawback in case of external fault. There might be CT getting saturated, as a result the output voltage might decrease and it can lead to the mall operation, that is even under external fault the relay might operate, which should not happen. So, in today's session, in order to prevent this, we are going in for the next type of protection, that is high impedance relaying scheme. Here the circuitry is going to remain the same. You are going to have the bus bar. To the bus bar on one side you are going to have the generating station being connected, on the other side you are going to have the feeders. As said earlier, the number of generating stations and the feeder need not be equal, because we are just going to measure the algebraic sum of the currents entering and leaving the section as per the Kirchhoff's law, right. So, just draw the generating station on one side and the feeders on the other side. Then what you have to do, just take the CTs and draw the differential connection. In the previous thing we were just connecting a relay, but in this section what we are going to do is that we are going to you should check in both for your internal and your external faults, and it should not mall operate on your external faults, for which instead of a normal relay we are going in for a high sensitive DC polarized relay. It is going to be connected in series with the tuning coil, LC as seen as a tuning coil. Okay, so this kind of circuitry we have seen in the earlier protection also, where we have seen in the transformer protection with harmonic restraining feature of the second harmonics. So, the same principle is employed here. Now, here what we are going to see, we are going to analyze both the cases, that is in case of the internal fault and in case of your external fault also it should not act on. So, it is also called as a biased or a percentage differential scheme. Here the additional setup here is a thyrite. It is nothing but it is used for draining the excessive over voltage to the ground during the heavy internal fault, and it is connected in series with a high set overcurrent relay. So, which I will be explaining in the later part. So, whenever a fault occurs, let us take whenever the external fault occurs, in that case we have designed this circuit. We are going to design the circuit in such a way that if I am going to have the normal relay here, so this relay is going to be very sensitive only to your differential current, that is your I1 minus your I2. So, only this differential current it is going to take care of, whereas the remaining current, that is your spill current, that is only spill current is going to pass through your relay for its operation. Suppose if it is going to consist of any DC or harmonics, so in that case due to your external fault, if it is going to consist of your DC and harmonics, the relay is set in such a way that it becomes insensitive, so that any drawback or the mall operation of the external fault is avoided. So, just if it is going to be sensitive only accurately to the spill current, and it is going to be insensitive to the DC and the harmonics. So, in this condition, thus this external fault drawback is overcome. Now, we will see about, suppose in case if there is going to be a heavy phase fault, internal fault is going to be there. In that case what happens? So, this heavy internal fault should not affect the system. So, we are giving a protective over voltage protection, that is your thyrite you are going to provide, as well as you are going to have a high overcurrent relaying, because so if at all a fault occurs, if at all a very heavy internal fault occurs, in that case, so this high set overcurrent relay will give a speedy operation, high speedy protection. Okay, as well as if you could see here, so the relay is set in such a way that it is going to be, the pickup current is going to be higher than that of the external fault, so that even if external fault occurs, the relay will not operate. So, you should set the setting in such a way the pickup current is going to be set greater when compared with your external fault, so that it prevents the operation or it prevents the mall operation during your external fault condition. Thank you. In the